hello students. We'll continue again with unit number 2 and topic number 3, which is energy generation plants and water provisioning. So the first one of energy generation plant is hydro energy generation. Hydropower plants capture the energy of falling water to generate electricity. A turbine converts the kinetic energy of falling water into mechanical energy. Then a generator converts the mechanical energy from the turbine into electrical energy. So hydro plants range in size from micro hydros that power only a few homes to giant dams like Hoover Dam that provide electricity for millions of people. Parts of a hydroelectric plant. Most conventional hydroelectric plants include four major components. The first one, dam, raises the water level of the water to create falling water, also controls the flow of water. The reservoir that is formed is in effect stored energy. Number 2, turbines. The force of falling water pushing against the turbine's blades causing the turbine to spin. A water turbine is much like a windmill except the energy is provided by falling water instead of wind. The turbine converts the kinetic energy of falling water into mechanical energy. Number 3, generator. Connected to the turbine by shafts and possibly gears, so when the turbine spins it causes the generator to spin also. Converts the mechanical energy from the turbine into electric energy. Generators in hydropower plants work just like the generators in other types of power plants. Number 4, transmission lines. Conduct electricity from the hydropower plant to homes and business. How much electricity can a hydroelectric plant make? The amount of electricity a hydropower plant produces depends on the following two factors. How far the water falls and amount of water falling. For how far the water falls, the farther the water falls, the power it has. Generally, the distance that the water falls depends on the size of the dam. The higher the dam, the farther the water falls and the more power it has. Scientists would say that the power of falling water is directly proportional to the distance it falls. In other words, water falling twice as far has twice as much energy. Amount of water falling. More water falling through the turbine will produce more power. The amount of water available depends on the amount of water flowing down the river. Bigger rivers have more flowing water and can produce more energy. Power is also directly proportional to river flow. A river with twice the amount of flowing water as another river can produce twice as much energy. Number 2, solar hydroelectric generation. Solar power is the conversion of energy from sunlight into electricity either directly using photovoltaics, PV, indirectly using concentrated solar power, or a combination of both. Concentrated solar power systems uses lenses or mirrors and solar tracking systems to focus a large area of sunlight into a small beam. Photovoltaic cells convert light into an electric current using the photovoltaic effect. Photovoltaics were initially solely used as a source of electricity for small and medium-sized applications, from the calculator power by a single solar cell to remote homes powered by an off-grid rooftop PV system. Commercial concentrated solar power plants were first developed in 1980. As the cost of solar electricity has fallen, the number of grid-connected solar PV systems has grown into the millions, and utility-scale photovoltaic power stations with hundreds of megawatts are being built. Solar PV is rapidly becoming an inexpensive low-carbon technology to harness renewable energy from the sun. The current largest photovoltaic power station in the world is the Pavagara Solar Park, Karnataka, India, with a generation capacity of 2050 megawatts. Wind wave energy generation. Wave energy or wave power is the transport and capture of energy by ocean surface waves. The energy captured is then used for all different kinds of useful work, including electricity generation, water desalination, and pumping of water. Wave energy is also a type of renewable energy and is the largest estimated global resource form of ocean energy. Wave energy is also known as ocean energy or sea wave energy. It is an energy harnessed from ocean or sea waves. So the rigorous vertical motion of surface ocean waves contains a lot of kinetic or motion energy that is captured by wave energy technologies to do useful tasks. For example, generation of electricity, desalination of water, and pumping of water into reservoirs. Wave energy or wave power is essentially power drawn from waves. When wind blows across the sea surface, it transfers the energy to the waves. They are a powerful source of energy. The energy output is measured by wave speed, wave height, wavelength, and water density. The more the strong the waves, the more capable it is to produce power. The captured energy can then be used for electricity generation, powering plants, or pumping of water. It is not easy to harness power from wave generator plants, and this is the reason that there are very few wave generator plants around the world. Sorry. There are multiple different technologies used for wave energy, and there are 5 main types of technology used, including absorbers, attenuators, oscillation water columns, overtopping, and inverted pendulum device. So sorry again. Okay. Next, absorbers extract energy from the rise and fall of the waves with a buoy. Once the energy is extracted, it is then converted to electrical energy with a linear or rotary generator. Attenuators capture energy by being placed perpendicular to the length of the wave, which causes the attenuator to continuously flex where segments are connected. This connection is then connected to hydraulic pumps, which converts the energy. Oscillation water columns (OWC) is a partially submerged enclosed structure. The upper part of the structure above the water is filled with air, and incoming waves are funneled into the bottom part of the structure. When these waves come through the structure, it causes the water column to rise and fall with a wave, which causes the air in the top structure to pressurize and depressurize. This in turn pushes and pulls air through a connected air turbine at the top of the structure, converting the energy. Overtopping has a wave lift over a barrier which fills a reservoir with water and is then drained through a hydro turbine. This technology is very similar to a conventional hydropower dam. Inverted pendulum device uses the motion of waves to move a hinge paddle back and forth. The motion of the paddle drives hydraulic pumps, which drives electrical generators. Next one is tidal energy generation. Tidal power or tidal energy is the form of hydropower that converts the energy obtained from tides into useful forms of power, mainly electricity. Tidal energy has potential for future electricity generation. Tides are more predictable than the wind and the sun. Among sources of renewable energy, tidal energy has traditionally suffered from relatively high costs and limited availability of sites with sufficiently high tidal ranges or flow velocities, thus constricting its total availability. However, many recent technological developments and improvements both in design and turbine technology indicate that the total availability of tidal power may be much higher than previously assumed, and that economic and environmental costs may be brought down to competitive levels. Tidal power is taken from the Earth's oceanic tides. Tidal forces are periodic variations in gravitational attraction exerted by celestial bodies. These forces create corresponding motions or currents in the world's oceans. Due to the strong attraction to the oceans, a bulge in the water level is created, causing a temporary increase in the sea level. So as the Earth rotates, this bulge of ocean water meets the shallow water adjacent to the shoreline and creates a tide. This occurrence takes place in an unfailing manner due to the consistent pattern of the moon's orbit around the sun. The magnitude and character of this motion reflects the changing positions of the moon and sun relative to the earth, the effects of Earth's rotation, and local geography of the sea floor and coastline. Tidal power is the only technology that draws on energy inherent in the orbital characteristics of the Earth-Moon system and to a lesser extent in the Earth-Sun system. Other natural energies exploited by human technology originate directly or indirectly with the sun, including fossil fuel, conventional hydroelectric, wind, biofuel, wave, and solar energy. Nuclear energy makes use of Earth's mineral deposits of fissionable elements, while geothermal power utilizes the Earth's internal heat, which comes from a combination of residual heat from planetary accretion and heat produced through radioactive decay. A tidal generator converts the energy of tidal flows into electricity. Greater tidal variation and higher tidal current velocities can dramatically increase the potential of a site for tidal electricity generation. Because the Earth's tides are ultimately due to gravitational interaction with the Moon and Sun and the Earth's rotation, tidal power is practically inexhaustible and classified as a renewable energy source. Movement of tides causes a loss of mechanical energy in the Earth-Moon system. This is the result of pumping of water through natural restrictions around coastlines and consequent viscous dissipation at the seabed and in turbulence. This loss of energy has caused the rotation of the Earth to slow in the 4.5 billion years since its formation. During the last 620 million years, the period of rotation of the Earth has increased from 21.9 hours to 24 hours. The last one, geothermal energy generation. Geothermal energy is the thermal energy generated and stored in the earth. Thermal energy is the energy that determines the temperature of matter. The geothermal energy of the earth's crust originates from the original formation of the planet and from radioactive decay of materials. The geothermal gradient, which is in the difference in temperature between the core of the planet and its surface, drives the continuous conduction of thermal energy in the form of heat from the core to the surface. Geothermal power is cost-effective, reliable, sustainable, and environmentally friendly, but has historically been limited to areas near tectonic plate boundaries. Recent technological advances have dramatically expanded the range and size of viable resources, especially for applications such as home heating, opening a potential for widespread exploitation. Geothermal wells release greenhouse gases trapped deep within the earth, but these emissions are much lower per energy unit than those of fossil fuels. The Earth's geothermal resources are theoretically more than adequate to supply humanity's energy needs, but only a very small fraction may be profitably exploited. Drilling and exploration for deep resources is very expensive. Forecasts for the future of geothermal power depend on assumptions about the technology, energy prices, subsidies, land boundary movement, and interest rates. The last topic is water provisioning. Provisioning services are ecosystem services that describe the material or energy outputs from ecosystems. They include food, water, and other resources. Ecosystems play a vital role in the global hydrological cycle as they regulate the flow and purification of water. Vegetation and forests influence the quantity of water available locally. So this is your assignment number 4, weekly assignment number 4. You have to write about the futuristic system except for Hyperloop, meaning you have to write about a futuristic system, but that should not be about Hyperloop. And number 2, you have to explain in detail about the water provisioning system. Now you can give your name, section, and enrollment ID in the chat box for attendance, and also we'll see a video now for your better understanding.
Today, we are going to look at what a power plant is, different types, and why automation is important in the power plant business. Here at RealPars, we love making videos that help you to discover new and exciting topics. So if you enjoy viewing this video as much as we enjoyed making it, click the like button below. Remember to click subscribe and the little bell, and you'll receive notifications of new RealPars videos when they become available. So you'll never miss another one. In its simplest form, a power plant, known also as a power station, is an industrial facility used to generate electricity. To generate power, a power plant needs to have an energy source. One source of energy is from the burning of fossil fuels, such as coal, oil, and natural gas. Then we also have nuclear power. And finally, renewable energy sources, such as wind, solar, wave, and hydroelectric. Originally, the only source of power was direct current, or DC systems. But it wasn't until alternating current, or AC systems were introduced that the power could be carried the distances necessary to be suitable for distribution to the masses. Hydroelectric power plants generate power by converting the force of water to turn large generators. Hydroelectric power plants fall into 3 different categories. First up is impoundment. An impoundment facility typically uses a store of river water from a dam in a reservoir. When water is released from the reservoir, it flows through a turbine, which generates motion. This turning motion activates a generator to produce electricity. Next up, we have diversion. A diversion is fairly similar to an impoundment facility, but may not need the use of a dam, but works by channeling a portion of a river through a canal or a penstock. The last type of hydroelectric power plant is pumped storage. Pumped storage stores its energy by pumping water uphill to a reservoir at a higher elevation. When there is a demand for power, the water is released from the high elevated reservoir into a lower reservoir. This generates electricity when it flows through a turbine, generating motion and electricity. Thermal power plants generate electricity by converting heat into electricity, essentially by burning a fuel. One example of this is a nuclear power plant. Nuclear power plants use reactors' heat to turn water into steam. The steam is then sent through a turbine, which, as we've already learned, generates movement of a generator, which in turn generates electricity. A coal power plant works in much the same way, but instead of a nuclear reactor heating water to make steam, the heat from the burning coal powers a steam turbine. The next type of power plant we will look at is a solar power plant. This type of plant uses the sun's energy to convert into electricity. This is achieved by using photovoltaic or PV panels, made up from a number of semiconductor cells that release electrons when they are warmed by the thermal energy of the sun. Solar energy is one of the cleanest ways of generating electricity. The solar panels get connected to the grid and can be used to supplement a thermal power plant resources. They can be used in domestic environments too, and with the aid of batteries, can reduce households' energy consumption drastically without burning any fossil fuels. Last but not least, we have wind power plants. Wind power plants, or wind turbines, get their energy from the wind by connecting a generator to the blades. The rotational movement of the blades, caused by the wind, powers a generator. Like solar power, they are a clean source of energy, but require much more hardware to work effectively, and with many more parts, are more likely to fail. Like many things nowadays, power plants are controlled using a PLC, Programmable Logic Controller, or DCS, Distributed Control System. The ability for condition monitoring of all the plant items enables us to determine what is running efficiently and what could fail. This enables us to proactively maintain plant equipment before it fails, rather than reactively fixing broken equipment. From within a control room, a full SCADA, or a supervisory control and data acquisition system, can monitor and control temperatures, speeds of pumps and motors, and open and close valves. This can be especially useful in the case of fossil fuel burning plants, where the precise control of system devices can increase the plant availability. Availability is the amount of time that the plant is able to produce electricity over a certain period of time, divided by the amount of the time in the period, which is often a key performance indicator, or KPI. This also ensures the most efficient use of the plant, which maximizes power generation. By monitoring the demand and trending at which times of the day the demand is highest, plants can adjust the speed of pumps automatically according to the time of the day, something that wouldn't be possible without the use of an automation control system. That's it for this video. I hope you enjoyed learning about the different types of power plants and how we use automation to make them more efficient.